No, fingerprints. Right? Fingerprints. There's prints on a finger.
The next one.
Oh, fingerprint. Oh,
That's a joke.
I don't get it.
Joke.
oh my goodness.
Fingerprint.
Right.
It's a fingerprint.
Fingerprints. Prints. It's a pun.
Oh,
That's
yeah,
not like puns. Yeah, that's what we've been doing.
This is
No. Oh wow. Right.
oh, brilliant. Prints.
Right. Howdy. So hopefully y'all had a good fall break. Today we're going to start on LE4. So I'll introduce LE4 and then we'll have some time to do questions on whatever you're working on. So LE4 is basically implementing a recipe with several steps, and every step will have a timer. Once that timer elapses, we will print off that it's complete and then remove it as a dependency from steps down the line. So the input that we're going to have looks like this CSV file, where every line in the CSV is a step that we run. It has a time, so the time is going to be the amount of time we're going to give the timer, and the dependencies are whatever steps previously it needs to run before running itself. It's just like a Gantt chart where you have one step that depends on the other step completing. We're going to do this. We're going to implement this by having two different signal types. The first signal type is timer, which is a special case of signal. And then the second one is just plain old signal, where we use signal and raise. We'll be using the sig timer min as the signal for timers, and sig user 1 as our signal for the handler to remove dependencies. Cool. And then your output should look like this, where every step that's ready to be run will output that it's ready. You'll create a timer when we're ready to be run. And then when it elapses, we'll print off that it's complete. And once it's complete, it will wipe all of the dependencies, it'll wipe itself from the dependency list of the step. So when step 1 completes, you can see that 6 depends on step 1. So we're going to remove 1 from 6 and bless you. And then check if 6 is ready to be run. It is, so we're going to start that time. And then you run this until the number of steps that are complete equal the total number of steps in our recipe. Any questions about this, like our goal here? Okay, sweet. So let's continue. Yeah, like I said, we'll use sig timer min, sig RT min as the signal for timers, and sig action. So we're using sig action specifically because it associates a sig info object. That sig info object will hold the structure that points to our step. And this is just so that we know what step completes when a timer elapses. And then once the timer completes, we will push that to a completed step list and then raise this sig user 1 signal. When that sig user 1 signal is raised, it should be associated with this remove dep handler. What that handler does is it scans all of the steps and removes the signal that just completed from the next steps. So is that pretty clear? So a signal is just an interrupt that if there's an associated handler, that function will run when that interrupt is called. So the CPU is going to pass control from the current executing process to the handler that was associated with the signal. So in this way, we're getting like one step closer to concurrency. And signals are super useful. Like in industry, I think I've used timers in all of the projects that I've had. It's a super common thing. This is useful. Outside of this class, definitely. Cool. Any questions on this? Great. So specifically for creating a timer, you're going to be using sig action to associate the handler and the sig action struct with the sig min, and then make timer does all of the setup required to create a timer. So you don't need to, this makes it easier for your implementation. So timer create and timer set time creates a timer and starts it with a time. We're going to save off the step value, so the struct step, into this SI val pointer, just so that we know what step completed when the timer elapses. Yeah, and then timer handler is where we'll print off that the step completes and that you can now remove it from the dependency lists. So let's look at the code for this guy. Okay, so if we look at master chef, you can see that in our main, we have 3 different sections we need to complete: section 1, 2, and 3. Section 1 is your main, where the first 2 lines that you need to do is associate sig min with the sig action. So we've given you sig action that has the SA sig inflow flag. And then the main thing that I want to point out is that we have this timer handler. So that's the function that we're doing at sig action. So when sig action is triggered, it's going to say, okay, do this function. So we're going to be using sig action here. If we look at the man pages, those are pretty helpful. And sig action. So it takes in a signal number, which is just going to be sig min, so it's the signal that we care about, plus the sig action struct. That's the same struct that we just created here. And then old act, don't worry about this. We can have this as null pointer. That's just because you would use that if there was an old function that you wanted to default to, but we don't have that. Yeah, so this is everything that you need to set up the handler to be called when a time elapses. The next thing you have to worry about is this time handler, where we will check to see what step completes by casting that SI val pointer to a step. Then you run the print complete. So in our step, you can see that we've given you this print complete function. So that'll format the line the way that we expect it to be formatted. So you print that it's complete. Then you increment the complete count. This complete count is just to keep track of whether or not we're done. Whether or not we're done. And then push to complete steps. So completed steps we use to remove dependencies in our handler for remove dep. Once you've done those things in this line, you will now say that we're ready to remove the dependency, so we can raise the signal for remove dependency. And for that signal, we're going to be using sig user1. So to associate the sig user1 signal, we're going to be using the signal function. So that'll get called every time sig user1 is raised. And what remove dep handler should do is it looks through that completed step list and it will call remove dependency on our step list. So we've given you this step list class and it already has this remove dependency. So if you iterate through all of the steps that have been completed and call remove dependency on the whole list for every step that's been completed, that should be good enough. And this step list has already been parsed and created for you in the main. So you can see that recipe steps gets populated. So that's like essentially a wrapper for the list of all steps that your recipe has. Yeah, so that's everything about the handlers and how you set them up. Any question on like what your handlers are supposed to do or how you associate them? Okay. Cool. So the last part of main is that we are going to have it in a while loop. So we want to run this part of the code until we have completed every step. So that's really until completed count is the same as recipe steps. And you'll also see in step list, we've given you this count. So you can compare against completed step and count. So until we're done, we're going to check to see what steps are ready to be run. Again, in step list, we've given you this get ready steps. So this will return all of the steps that have a dependency or that don't have any dependencies, or they've all been complete and they're not currently run. So whenever you start to run a step, I'd recommend setting this running to true, just so that that is ready isn't gonna like give you duplicate steps. Once you have the ready list, then you can iterate through that ready list and make timers for all of them. So make a timer for each and set it to be running. That's about it. It shouldn't take too much code to complete, maybe about 20 extra lines, 20 lines in addition to this code. Let me see. Let's go back to the PowerPoint, see if there's anything I missed. Yeah, once the time has elapsed, you want to print that it's complete and then call remove dep handler, which will handle wiping it from the completed steps. We're doing this because this does help concurrency. Yep. And this is more details about all of the parts of the MasterChef that you need to complete. So associate the handlers. Can you continuously check recipe steps for ready steps that are ready to start them with make timer. That's what your handlers are supposed to do. And this is just make timer. This make timer has already been completed for you. It's just helpful. Step list and step also have already been completed, but you can see these are probably the functions that you're going to be using, where get ready steps returns all steps that are ready. Remove dependency searches through the list and removes them if that dependency exists. Print complete formats the line nicely. Running says if it's ready to run or not, or if it is running. So these are all of the system calls that we're going to be using. So take a look at the man pages for that. Also, the lecture on signals would be helpful. I think that's everything I wanted to touch on. Are there any questions I can go over? I think this LE is really fun. I had fun making it, so hopefully, yeah.
He's somewhat similar to what we did on correct?
No. So the similarity between LE3 would be you're checking to see if a step is ready to be run. But the way that we're using timers instead of a run function. And it's more signal implementation. But if it helps thinking about LE3, definitely. Cool. Any other questions? Okay, cool. I'll be around. Have fun. Do coding.
So you just did it? No, I didn't just